All right, welcome to Chapter 3. Today's lesson is on computer assembly. And we're going to take a look at computer assembly and also replacement of some computer parts in this chapter. This chapter is in preparation for the hands-on lab of assembling the computer, and over the next few weeks we will be taking the computers apart and putting them back together. So you want to become comfortable with doing this. I've also uploaded a YouTube video in the lessons for the class, so you want to take a look at that one on computer assembly. It's a really nice one. So these are some of the things that we're going to look at today: opening the case, installing the power supply, attaching the components of the motherboard and how to install the motherboard, installing internal drives and drives in the external bays, installing adapter cards. We're also going to install and connect all the internal cables, reattach the side panels and connect the external cables, boot the computer, and configure the BIOS. Here are some of our objectives for today. We're going to look at our reasons for upgrading computer components. We're going to learn how to select and install replacement or upgrading the motherboard, the CPU, heatsink, fan, and the RAM. We're also going to take a look at upgrading and configuring the BIOS, and we'll also look at selecting, installing replacement or upgrading the hard drive, and selecting, installing replacement or upgrading input and output devices, such as your keyboard and your mouse monitor. So the first thing that we're going to need to do is open the computer case. Now remember, you want to do this in a properly set up lab or environment to work on your computer. That would consist of having it on an anti-static mat and wearing your anti-static wristband. Remember, when upgrading or assembling your computer, you want to keep parts so that they're assorted on your work surface properly. Keep them in their anti-static bags until you're ready to put them in the computer. Now, there are different methods for opening the cases, and you want to consult the manual or the manufacturer's website when doing this. Sometimes there's screws, sometimes they're thumb screws, things that you can do by hand. It all depends, and just don't assume that every case is the same. So to install the power supply, you want to insert it in the case. You want to align the holes up of the power supply in the case, and you want to make sure that it is secured with the correct screws and that it's not going to move. If it's not secured properly, it could damage the computer. So we're going to talk about some of the things that we're going to attach to the motherboard before we actually put it in the case. It makes it easier to work on the computer if we install the CPU, the thermal compound, the heatsink and fan assembly, and we install the RAM before we install the motherboard. Some other technicians will say put the motherboard in first and then you can add these things afterwards, but in the Cisco manual it recommends that you install them first. Whenever you are going to add the CPU, install the RAM and the heatsink, you want to make sure it is all appropriate for the motherboard and the case. So you want to make sure that you're following the form factor. Make sure that, again, when you're working on the computer, that you discharge any electrostatic that you might have built up. Remember, always touch the metal of the computer. When you are putting the CPU in, you want to make sure that it lines up properly. Make sure that you do not touch any of the contacts and you do not force it. If it does not want to go in easily, then you might not have it set up right. Remember, there's usually a little triangle on the CPU and also on the socket. Make sure your CPU is the correct CPU for the type of socket you're using. Remember, there are different sockets. You're going to need to add thermal compound, and you'll do that. Make sure it's clean, and just put a little dime size on, and then you'll press it down when the heat sink goes on. Remember, the heat sink is what pulls the heat off of the CPU when it's working. The thermal compound allows this to happen. It gets the heat from the CPU out to the heat sink, and then the fan usually dissipates that from the computer. You're going to install your RAM next. Remember, you're going to line up your keyed points. Make sure you have the proper RAM for your CPU and motherboard. Also, remember, we have done this in class. You'll usually use your thumb and your index finger and apply light force. You want those white contacts on the end or clips to push up on their own. You do not want to do those manually. The motherboard itself. So when you have all the components installed, you're going to put it in the case. You want to make sure that it sits on the metal standoffs or plastic ones. Sometimes they're plastic or metal, and you want to use the appropriate amount for your form factor and your particular motherboard. Just don't cheat and leave a few out. It could affect your computer, how it runs. Next, we're going to talk about installing our internal drives. So the first type of drive is our HDD or our hard disk drive. Usually there is a particular slot for that to go in, and you want to make sure that you align it up in the 3.5-inch drive bay. You'll insert it in the bay. Depending on the type of mounting bracket, you might use screws, or it might clip into the particular slot that it's going to go in. If you're using an SDD, a hard drive that is a solid state SSD drive, then you want to make sure you use the right brackets for mounting that also. Then we can install our drives in our external bays. This would include optical drives and floppy disk drives, our FDDs. Our optical drives are our CDs, DVDs, and BDs, Blu-ray players. You want to make sure that they are in the correct spots, and that you make sure you use the proper mounting brackets for those. Next, you would install any adapter cards. Remember, your adapter cards allow you to expand the functionality of your computer. These cards could be network interface cards or NIC cards, wireless NIC cards, or video adapter cards. There are different slots, so you want to make sure that your card is the correct slot. They could be PCI or PCI Express. They also could be for video, PCI AGP or PCIe expansion slots. Sometimes, depending on the adapter card, you might need to add power to it, and there will be a cable that will go to your power supply. That will vary by vendor and manufacturer, and also when installing cards, you want to keep in mind that you have enough watts or enough power output from your power supply. You could damage your components of your computer and your power supply if you do not follow the correct recommendations of the card manufacturer. Some internal cables that we would need to use to distribute our electricity from the power supply to the motherboard. We have ATX, AUX, SATA, Molex, and Berg. You want to become very familiar with these so that you're easily able to identify them. And remember, Berg over here is used for your floppy drives. And SATA power is going to be used usually with SATA data cables also for our hard drives. One thing to remember is that when you're doing SATA for our computers, they're usually one SATA for the data going directly to each hard drive. So then we have our data cables. We have PATA, SATA, and floppy drive data cables. And again, you want to become familiar with each type of the cables. Again, if you have multiple hard drives in the SATA type of cabling, you will have a direct SATA cable coming from the motherboard to the hard drive for each hard drive. For our PATA, they're usually a cable that has multiple slots or connectors on it. And then you're going to also make sure you connect all the cables from the front of the computer case for your buttons and your lights to the motherboard. Again, you're going to make sure that you consult the manual or the vendor's website for how these should be hooked up correctly. And then once you've installed all the internal components, you want to reattach the side panels and then connect your external cables. And those external cables would be the cables that are going to connect your motherboard and your keyboard and your mouse and any USB devices or Ethernet. And then the last thing you want to connect is your power. Again, remember your power should always be disconnected when you're working on your computer. And then we're ready to boot the computer for the first time. The first thing our computer is going to do, it's going to do the BIOS, it's going to do the basic input-output system, and it's going to do our power on self-test, or our post. You want to become familiar with BIOS and post. The BIOS contain a setup program used to configure our settings for our hardware devices, so our computer can use the different hardware devices attached. And usually it's a special memory chip. It's our CMOS, or our complementary metal oxide semiconductor. And it can be saved in non-volatile memory, which does not need power to retain its settings. So when you turn the computer off, those settings are going to be retained. The post checks to see that all the hardware in the computer is operating correctly. If a device is malfunctioning, then an error or beep code will alert the technician that there is a problem. So the number of lights we see or the number of beeps we hear can tell us what could possibly be wrong with our computer. So our BIOS configuration. So a technician will use the BIOS information to learn about the installed components, our CPU, our RAM, our hard drive, and our optical drive. Technicians will also use the BIOS to set the time and date, disable any devices, set the boot order. So if you want to boot from a CD or from the hard drive, or if you have multiple hard drives, you would set the boot order in the BIOS. Adjust your clock speed and enable any virtualization that you might have running on the computer. Some other things that we can do for security features with our BIOS is we can set a password. So that means a person could not even boot the computer up and install or overwrite the existing system without entering a BIOS password. We could set up drive encryption. You could create a trusted platform module. And then there's some other things, installing a LoJack, which will allow the computer to be locked remotely if the computer were lost. And also it would display information for a lost computer so it could be returned to the owner. Or in the case of being stolen, it could delete any sensitive data on the computer. And it also would allow the computer to be located via a geotechnology, so a GPS type of information to allow our user to find it if it was stolen or lost. Kind of like what's in your smartphones, I suppose. So our BIOS configuration, it also does some hardware monitoring. It's going to monitor our temperatures of our computer, our fan speed, our voltages, our clock and bus speeds, any intrusion detection, and it's going to do built-in, it has built-in diagnostics, so it can do a start test, hard drive test, and memory test. So if you were thinking that your computer had issues with the hard drive or memory, maybe it's shutting down frequently, then you could do this from the BIOS. So now we're going to talk about upgrading some of the parts on our computer. So not a complete assembly from scratch, but we have something fail on our computer, or we want more power or more storage. We're going to talk about upgrading some of the components of our computer. So if the motherboard is upgraded or replaced, the CPU may need to be replaced. One of the things you're going to need to take into consideration, maybe you have an older motherboard and now your CPU is not compatible. Or maybe your motherboard burned out, you can't fix it, and you would like to use the same CPU. So then you're going to check to make sure what is the type of socket that is on your computer. What is the architecture of that CPU? And you want to make sure the motherboard would have that type of CPU socket. So these are some of the interfaces. We have ZIF, which is zero insertion force. We have LGA, which is land grid array. We have PGA, which is pin grid array. And then SEC, which is single edge connector. And then low insertion force, LIF. These last two I mentioned, are not commonly used any longer, I should say. So upgrading the CPU. Remember, a new CPU must fit into the existing CPU socket on the motherboard. It must be compatible with the motherboard chipset. It must operate with the existing motherboard and power supply, so you want to make sure that you have enough power from the power supply, or watts, for this CPU. And it also must operate with the existing RAM. So then, you might need to upgrade the RAM. And it also might require a different heatsink or fan assembly. Maybe your old CPU did not have a fan with it, and it was just a heatsink. Now, if it's a bigger CPU, faster, you might need to get a heatsink with a fan assembly. The RAM. Sometimes we will need to upgrade RAM for our customers. Their computer might come with 2 gigabytes or 1 gigabyte, and they want their computer to be able to run a little bit faster, do more tasks at the same time without freezing up, so they'll want to upgrade the RAM. So you're going to need to find out what type of RAM you already have. What type of modules can you use? Sometimes when we upgrade from 1 gig to 4 gigs, if that were the case, we might not be able to use the RAM that's already there. So we might need to buy all new RAM. Also, does the new RAM chip match the speed, latency, type, and voltage of the existing RAM? So things to take in consideration if you're doing an upgrade. A great way to figure this out is to go in, find out what kind of RAM is in your computer, what was specified when the computer was manufactured, verify that that's actually what is in the computer, and then do a Google search, see what you can put into it to upgrade the computer. I always caution people when doing upgrades, though, with older computers when it comes to the CPU, the RAM, and video cards to make your computers a little bit faster or do more things. Sometimes it's better just to replace the computer in totality for the whole computer, because you might end up replacing the RAM and then the hard drive or the graphics card, and that actually spend more money, or maybe your motherboard wasn't strong enough to support all those new devices. The BIOS. So periodically the manufacturer is going to release an update for the BIOS. Our BIOS today, the chips are EEPROM. So make sure you know what EEPROM is. We discussed this already in Chapter 1. Or it's flash memory. And this is memory that can be upgraded by the user without opening the computer case. So when we do this, this process is called flashing the BIOS. And we do this through a command prompt. Several motherboard manufacturers provide software that allows a user to flash the BIOS from within Windows. So you would install a piece of software or look for software that came with your computer to allow you to update your BIOS. Again, you could do a Google search, go to the vendor or manufacturer's website to see if there have been any updates to the BIOS. Remember, the BIOS is your basic setup information for the computer, getting it to start before it loads the operating system. Storage devices. This is a common thing that will get upgraded, and it could be because they need more memory, they want additional memory, or they have a hard drive that has failed. You want to make sure that you meet some factors to do this. You're going to need to verify what kind of hard drive that it can take. Is it PATA or SATA? When you connect two PATA hard drives, you're going to need to, and they're connected with the same data cable, one drive must be jumped as the master and the other must be jumped as the slave drive. When you're using a SATA hard drive, it has its own data cable and there's going to be no master-slave relationship between those drives. We also have RAID when we have multiple computers, so redundancy array of independent disks. And this, when we do this type of installation, it can provide data protection and increase performance when connecting multiple hard drives. So the RAID level and the number of drives for the RAID will allow us to do certain things, error checking, disk mirroring. So depending on your customer's needs, you might need to set up a RAID type of system. Remember to look this further, read the information in the chapter readings. So then we have input-output devices. And our input-output devices can be our keyboards, the mouse, the monitors. You sometimes will use the existing slots for this, or sockets, or you might need to use expansion slots, like adding a graphics card. You might be able to connect some of these via a USB connection. If you do not have a USB connection, you might be able to install an adapter card to add additional USBs, or add a USB hub. Sometimes when we install additional input-output devices, we might need to install drivers for these. Again, you're going to need to consult the vendor and the manufacturer for each one of these particular devices. So that was the end of Chapter 3. It's quick, it's just an overview, so you can do the hands-on. Again, you want to be comfortable with your computer assembly, installing all of the internal computer components, connecting your cables. You want to understand how to describe and configure a BIOS, and you want to be comfortable with the description of the post. Remember, we also talked about upgrading and configuring our PC, our motherboard, and related components on the motherboard. Remember, when we're installing a motherboard in a computer, it's best to install all the components such as the CPU and the RAM and the heatsink and the fan outside of the case. But if we're doing an upgrade and we're just upgrading the CPU or the RAM, we would not need to remove the motherboard for that. We also talked about storage devices today, whether it's hard drives, floppy drives, solid state drives, or optical drives. You want to be comfortable with doing those upgrades, installations, and also adding input and output devices. So that is the end of chapter 3, and become comfortable with this, and then we'll get hands-on in the lab. Alright, until next time, have a great day. I'll see you in the lab.